Hello everyone, today we will learn and understand how to evaluate a machine learning model using the evaluation metrics like mean absolute error, mean squared error, root mean squared error, and R-squared score. For this, we are going to use following dataset, which is of a house price prediction. Here, at first, we have imported the required libraries like pandas for data handling, numpy for numerical operations. Then from scikit-learn, we have imported random forest regressor for building the model and metrics for evaluation. Then we have loaded our dataset. After that, we have done the selection of features and targets, where we have selected the numerical features which are important like overall quality, living area, garbage capacity, and basement area. And our target variable is sale price. Then we have split the dataset into 80% training data and 20% testing data. Then we have trained our random forest model. Here, random forest build multiple decision trees and averages their prediction. Then we have made prediction. Now, the trained model predicts house prices for unseen test data. Now, let's understand the evaluation metrics. So, our first evaluation matrix is mean absolute error or MAE. So, mean absolute error measures the average absolute differences between actual values and the predictions. It does not square the error, and lower mean absolute error indicates better accuracy. In simple terms, we can say that mean absolute error is the average mistake made by the model. If a house price is like of 2 lakhs, then our model will predict around 1 lakh 82,000 or 2 lakh 17,000. In our case, the mean absolute error is the following figure. So this means on average our prediction is off by this following figure. Then comes the mean squared error or MSE. So mean squared error squares the error before averaging them. Because of squaring, large errors are penalized more heavily. If one prediction is wrong, mean squared error increases a lot. That's why we use mean squared error to detect large mistakes. Lower mean squared error is better. In our case, the mean squared error is of the following figure, which is quite large, and the value is large because errors are being squared. Then comes the root mean squared error or RMSE. So root mean squared error is simply the square root of mean squared errors. It brings the error back to its original unit for the house price in our case. Here, root mean squared error is easier to interpret than mean squared error because it is the same unit as price, and lower root mean squared error indicates better model performance, same as mean squared error. In our case, the root mean squared error is of the following figure. This means prediction typically deviates by the following figure. Then comes the R squared score. R squared measures how well the model explains the variation in the target variable, and it ranges from 0 to 1. Here, if R squared is equal to 0, then model explains nothing, while if R squared is equal to 1, then it makes perfect prediction, and higher R square indicates better model performance. In our case, the R square is around 0.87. This means the model explains 87% of the variation in house prices. So we have seen that mean absolute error provides average prediction error, mean squared error penalizes large errors, root mean squared error gives the realistic prediction deviation, and lastly, root squared score tells us overall model performance. Here, lower indication of mean absolute error, mean squared error, and root mean squared error, and higher indication of R squared score indicates a good performing model. Thank you.